I will now solve LeetCode 239 sliding window maximum. We already had a solution for this problem, an order-n solution using monotonic DAG. But this time I will be using a 3 set or 3 map to solve this problem. The running time will be n log n, but this is another way to solve the same problem, and it's good to know multiple solutions. The question is, you are given an array of integer nums, and there is a sliding window of size k, which is moving from the very left of the array to the very right. You can only see k numbers in the window. Each time the sliding window moves right by one position, return the maximum sliding window. So let me show you an example. Assume that the sliding window size k is equal to 3, and this is the input array. The initial window is only containing the first 3 numbers. We take the maximum, which is 3, and put it to the answer. Now we move the window one cell to the right. Then now the maximum number within this window is 2, so we put it into the output and move the window again. This time the window contains 1 to 1. The maximum is still 2, so we put it into the output result. We move it again. This time the maximum is 3, and we move it one more time. The maximum now is 4. All right, so the way we can approach this problem, again, we solved it using a monotonic DAG, but here what I'm going to do is the following. I'm going to use a map this time, a 3 map, so that the values are sorted. The reason I'm using a 3 map is because there are duplicates in it, and I need to make sure that when a number moves out of the window, if there's another number of the same value, I do not erase it. So initially, I'm going to compute the frequency of each number in this window. There is 1, 1. And then there's 2, 1, and 3, 1. So the first value in here is the number, and the second one is the frequency. So as you can see, there is 1 of 1. There is a 2 from 2. There is only one of them. From 3, there is only one of them. And because these are stored in a 3 map, the maximum value is always at the end. I can ask, give me the maximum key. That's 3, so I get the maximum key value and put it into the result. Now I move the window. When I move the window, I need to erase, this value is now out of the window, so I need to decrement its frequency. It becomes 0. Because it becomes 0, I need to remove it from the window. Now a new number comes into the picture, into the window. So this 2 now enters the window. So I need to, if it doesn't exist, I need to insert it. Because there is already a 2 in the window, I need to just increment its frequency. So this says there is only 1, and there are 2 2s in the window. Let's move it again. As you can see now, this 2 is moving out of the window. I need to decrement its frequency. So there is only one. There is only 1 2 within the window now, but there are now 2 2s, 2 1s. I'm sorry, there are 2 1s. So I need to update the frequency. Again, take the maximum. The maximum is 2. So obviously, before the maximum was 2. Here's the maximum is still 2, so I put it into the result. Now move the window again. 1 gets out of the window, so I need to decrement its frequency. It becomes 1. And now 3 comes into picture, so there is a 3 and there's 1 of them. And the maximum value is 3, so I put it into the result. Move the window again. Now 2 moves out of the window. The frequency becomes 0. Because the frequency becomes 0, I need to remove it. And 4 comes into picture, so I need to increment its frequency, and the maximum value at this point is 4. So that's the general idea. I'm going to keep track of the elements within the current window in a map, and just count the frequency of each number. And here is the actual code. Initially, I am creating a 3 map, and initially I'm just putting all k numbers into the 3 map, such that I increment the frequency. I count the frequency of each number. So the way to do that is you basically say, do you already have this number in the map? If you do, so get or default means if the number already exists, give me the value. If not, then return me 0. And I add 1 to it to increment the frequency, and I put this number back again. Again, if the number exists, it's going to just update the value. If it does not, then it's going to put it. So this is just the first window, the first window that contains the first k keys. Then I go into this for loop. I start from at k, go all the way to n. Initially, I take the last key, the maximum key, and put it into the result. And if you are at position n, we stop. Otherwise, this value now is getting out of the window, right? I'm now moving the window one cell to the right. So this value, I minus k, is now getting out of the window. So I get its frequency. If the frequency is greater than 1, I decrement it and update its frequency. Otherwise, I just remove it from the window. And now nums I is getting into the window. So again, I need to update its frequency. Again, it's the same idea. Get its current frequency or 0, update it, and put it into the window. And at the end of the loop, at the end of this loop, I just return the answer. So let me run this thing so that you see that it actually works. It is going to be slow. Yeah, as you can see, it's just 6.08%. Because this is an n log n solution, and the best solution for this problem uses a monotonic deck to solve this problem in order and amount of time. Any questions you might have, please leave them in the comments section.